Now it's time to actually turn to the arithmetic of portfolio management. And so what we've got in front of us now is portfolio management risk and return. In particular, we're going to be looking at part one. So what we'll see here is sort of the basics. So it's going to be a little bit rudimentary. And in particular, it is something that has lots of overlap with study session 2. So if you go back to the quant material, a lot of this we will have already covered. I'm going to go ahead and go through it and we'll talk about it, but if you feel like, haven't we already seen that? Well, in fact, we have seen it before, so it's something that, yeah, you've seen before, but that tells you that if they're putting in here twice, well, it must be important, right? So anyway, so let's just jump in and see what we can learn about the material. So return measures. The first one is holding period return, and of course, we've talked about this in several places, and sorry, wrong tool with that. You've got to get to where you can see this in the formulas that you're looking at for the exam, those types of things. Well, the way this gets written is that the holding period return is equal to what we see here, P1 over P0 minus 1. Okay, you're also going to see it as being equal to P1 plus D1 over P0 minus 1. And then, so this is just the dividends or the cash flows you receive. Here we're assuming there are no interim cash flows. So it's not that it's different. It's just that this is if we're allowing for interim cash flows. And then we could also see it as P1 minus P0. What's that? That's capital gain, plus any cash flows that came. So D for the cash flows. All divided by P0, and notice that we do not have to put on a subtract 1 over here, right? So anyway, so all of these say the same thing. They're all holding period return, and this is a calculation that's just all over the curriculum. So, if you're going to buy something for 10 and sell it for 12, well, you calculate the return. That can apply to one day, 1 month, 1 year, 20 years, whatever it is. Whatever the holding period is the time between the observation of the prices. Average return. So if we're thinking of the average return on a portfolio, well, what is the then we can take the return of each of the individual assets divided by n, assuming that they were an equally weighted portfolio. This is simply an arithmetic average, not anything that I think is surprising to anyone. Okay, geometric return, we've seen this before, but again, the problem here is that compounding thwarts the idea of arithmetic return. So if we look at a 2-period investment, so that says time 2 there. If you start with $100 and you go to $200, okay, well that means you had 100% return in this period, right? And then if you go from $200 back down to $100, well you had a minus 50% return in this period, right? Well, if you calculate the arithmetic average, you take, 100 plus a negative 50 and divide it by 2, well then what you get is 25%. So do you feel like if you started with 100 and end with 100 that you were earning an average of 25% per year? Well, no, you don't, right? So what the arithmetic return does not allow for the compounding effect, the geometric return does. So the impact of investing and earning 10% 1 year, 12%, minus 2%, 4% for however many years, okay, well, that's what the geometric return is telling us. So you may have heard that large cap stocks in the United States over the last 60 or 70 years have had an average return of 12%. And then you start thinking, well, if my great grandfather had invested $1,000 for me, for 60 years at 12%, how much money would I have today? Okay, well, you would be a happy camper if you did that calculation, of course. But that would not be what you actually had, right? This 12% is an arithmetic return. The geometric return is going to be lower than that. It's closer to 10% or something like that, 10.2 or something. Anyway, so the point is, arithmetic returns, if there's any variation, okay, if we take, if we want to average 2, 2, and 2, it doesn't matter if we take the arithmetic or the geometric return. But if you want to average, 4, 0, and 2, so now we have, variation in the time series. Well, the arithmetic return will always be higher than the geometric return. So this is something that I do think will show up on the exam. So I would make sure that I could work with these geometric returns before there's two situations where we're going to get straight lines that I think show up and sometimes confuse people. So one of them was when we said, okay, we've got, asset A up here and asset B down here, and if they're perfectly positively correlated, then we get this straight line combination. All right, that's true, but that's not what we're talking about here. This actually falls out of a different part of the formulas if you want to think of it that way. So now what we're talking about is having any risky asset. So any risky portfolio here, we'll call it portfolio P. Okay, and what we're going to add is the idea of a risk-free asset. Okay, now what are the attributes of a risk-free asset? The attributes are, one, the standard deviation is 0. Okay, but also the covariance of the risk-free asset with all other assets is 0. It doesn't vary, right? You get exactly what you were promised. So, it has 0 variance and 0 covariance. And what that means is that we are going to get, if we say, well, I want to combine any portfolio P out here, okay, any portfolio P with the risk-free asset, then portfolio combinations there will lie on a straight line. All right. So another way to form a straight line, you can either have perfectly positively correlated securities, okay, or you can have a riskless security. You're going to get a straight line with all the portfolio mathematics. So what does this say? Well, if we're at this point, okay, down here, that says I've got half my money in portfolio P and the other half in the risk-free asset. Okay, well, if I really like portfolio P, maybe I want to move out. So I'm going to move, closer to P, or maybe I'm going to be all the way out here at P. But what if that's not enough risk for me? Well, what I could do, at least in this tightly woven theoretical world, is I could move up above that, right? So I could move up here by doing what? Putting all of my money in P and then borrowing at the risk-free rate, or shorting T-bills if you want a practical answer, right? So I can short T-bills and move up here, all right? Well, when we do this, all right, when we take a risky asset, okay, so any risky asset here, okay, and we combine it with the risk-free rate and we form the resulting straight line like this, okay, that's called a capital allocation line. All right, so we can move up and down this line through portfolio combinations down here, 100% risk-free, here 100% in the risky portfolio, here 50-50, here 150 and minus 50, right? So we can move up and down this line, okay, as a capital allocation line. So how are we going to decide where we as an individual investor want to be? Okay, well, we're going to do that by deciding what our risk-return preferences are. And our risk-return preferences, if you think way back to the econ material, are going to be determined by indifference curves. So what we see here is that investor A is and again, more risk averse. That's hard. He's risk averse. Okay, a better language there would be less risk tolerant. Okay, so the investor A is more risk averse than investor B. He has a steeper slope to his indifference curve, which says for this investor to take more risk, requires a lot of return. Investor B is also risk averse, but has lower risk tolerance. So to get him to move from out here to from A portfolio to B portfolio, well, you have to offer him the required increase in return per unit of risk is lower because of the slope of his indifference curve. All right, and of course we studied those back in economics. All right, it turns out that this CAL, the CAL or CAL, capital allocation line, is an important construct that's going to show up very early as we make the transition from portfolio theory, which is Markowitz, to capital market theory, but that's for another reading. Hope you get on top of this stuff. It's great practice. Make sure that you're okay with the basics. The stuff that's in this reading absolutely will show up on the exam. Now, it may not be the answer to the question, but you're going to have to use and it will be the answer to some of the questions. But you're certainly going to have to use the tools in here to answer other questions, both in portfolio theory and everywhere else in the curriculum. So, means and variances and covariances and, all that sort of stuff. This is just really fundamental to the CFA curriculum. So if you don't feel good about this particular reading, I would go back and work some more problems before I moved on. Good luck.